Have you ever wondered how the rushing water of rivers can be transformed into the electricity that powers your homes? Welcome to the fascinating world of hydroelectric power, where we harness nature's flow to light up our lives. This is energy conversion at its finest, where the kinetic energy of flowing water is transformed into electrical energy, powering everything from the smallest gadget to entire cities. At its core, hydroelectric power is all about capturing the motion of water as it flows downstream. Imagine a river gushing with water, tumbling over rocks and cascading down waterfalls. The water in the river is in motion, which means it has kinetic energy. Now, if we somehow manage to capture this energy, we could use it to do work, like turning an electric generator. This is exactly what a hydroelectric power plant does. It uses a dam to store water in a reservoir. When released, the water flows through a pipe or penstock and onto a turbine. The force of the water spins the turbine, which is connected to a generator. As the turbine spins, so does the generator, creating electricity. The electricity is then sent through transmission lines to power homes, businesses, and industries. But why is hydroelectric power so important? Well, for starters, it's renewable. The water cycle, powered by the sun, constantly replenishes the source of hydroelectric power. It's also sustainable. Unlike fossil fuels, it doesn't produce harmful emissions that contribute to global warming and climate change. Moreover, hydroelectric power plants have a long lifespan and relatively low operation and maintenance costs. They also provide ancillary benefits like water supply for irrigation and recreational opportunities such as boating and fishing. So that's the basic principle behind hydroelectric power, but where did this ingenious idea come from? Believe it or not, the use of water power dates back thousands of years. Long before the advent of modern technology, ancient civilizations were harnessing the power of flowing water to make their lives easier. One of the earliest examples of this can be found in the annals of ancient Greece, where water wheels were used to grind wheat into flour. This simple yet effective mechanism was the first stepping stone towards the development of hydroelectric power. The Greeks weren't the only ones to capitalize on this natural resource. As history moved forward, so did our understanding and usage of water power. From the watermills of medieval Europe to the ornate fountains of the Islamic Golden Age, water was seen as an invaluable source of energy and inspiration. But it wasn't until the 19th century that we began to see the true potential of water as a source of electricity. The first hydroelectric power plants were built during this time, marking a significant shift in our approach to energy production. The invention of the turbine, a device that converts the energy of flowing or falling water into mechanical energy, was a crucial development in this era. In the United States, the first hydroelectric power plant was built on the Fox River in Appleton, Wisconsin in 1882. This small plant, capable of powering just a few light bulbs, was a humble beginning. But it was a beginning nonetheless. Across the Atlantic, the United Kingdom followed suit, with the first hydroelectric power station being built in Cragside, Northumberland. The success of these early power plants proved that it was possible to harness the power of water on a large scale and set the stage for the development of the massive hydroelectric dams we see today. From the simple water wheels of ancient Greece to the complex power plants of the 19th century, the story of hydroelectric power is a testament to human innovation and our constant quest for better, more sustainable ways of living. The invention of the hydroelectric power plant was a game changer, but how did we get from there to the massive hydroelectric dams we see today? The 20th century was a time of rapid development for hydroelectric power. As the world's industrial prowess grew, so did the demand for reliable and sustainable energy sources. This need led to the construction of some of the most iconic hydroelectric projects, such as the Hoover Dam and the Grand Coulee Dam in the United States. The Hoover Dam, completed in the 1930s, was a marvel of its time. It was the largest concrete structure and the biggest hydroelectric power plant in the world when built. This colossal structure took advantage of the mighty Colorado River, turning its kinetic energy into electricity and supplying it to millions of homes across the American Southwest. Around the same time, another ambitious project was taking shape in the Pacific Northwest. The Grand Coulee Dam, the largest concrete structure in the United States when completed, harnessed the power of the Columbia River. This dam was a testament to the advancements in hydroelectric technology and engineering during the early part of the 20th century. But it wasn't just about size. The technology behind these projects also evolved rapidly. Engineers developed more efficient turbines and generators, enabling these dams to produce greater amounts of electricity. Innovations in construction techniques and materials also played a significant role. Concrete, for instance, was used extensively due to its durability and strength, allowing these structures to withstand the immense pressure of the water they held back. The 20th century also saw the rise of pumped storage hydroelectricity. This technology uses two water reservoirs at different heights, allowing power stations to store energy and release it when needed. This advancement enabled hydroelectric plants to respond quickly to changes in energy demand, further increasing their value and versatility. Indeed, the 20th century was a golden age for hydroelectric power. The construction of these gargantuan dams and the advancements in technology not only provided a reliable source of energy, but also transformed landscapes, fueled economies, and demonstrated the power of human ingenuity. These massive projects were a testament to human ingenuity and the power of nature. But what does the future hold for hydroelectric power? As we face the challenges of climate change, the importance of renewable energy sources like hydroelectric power is becoming increasingly apparent. Moving into the future, the potential for the development of hydroelectric power is immense. With an ever-growing global population and the consequent surge in energy demand, the need for clean, sustainable, and reliable sources of power is more pressing than ever. It's here that hydroelectric power truly shines. As a source of renewable energy, it's not just sustainable but also scalable. With the right infrastructure in place, we could harness the power of even the smallest streams to generate electricity. But as with all things, hydroelectric power comes with its own set of advantages and disadvantages. On the one hand, it's a clean source of power that doesn't rely on burning fossil fuels. This means it doesn't contribute to air pollution or the greenhouse effect. It's also a reliable source of power, with hydroelectric plants able to quickly ramp up or down production to meet demand. On the other hand, the construction of hydroelectric dams can have significant environmental impacts. They can disrupt local ecosystems and, in some cases, displace people and wildlife. However, with careful planning and the use of modern technologies, it's possible to mitigate many of these effects. Looking ahead, climate change poses both challenges and opportunities for hydroelectric power. Changes in rainfall patterns could disrupt the flow of water to hydroelectric plants, impacting their ability to generate power. But on the flip side, the melting of glaciers could create new opportunities for hydroelectric power in some regions. Despite these challenges, the future of hydroelectric power remains bright. Innovations in turbine technology, dam design, and environmental mitigation strategies are continually improving the efficiency and sustainability of hydroelectric power. As we move forward, it's clear that hydroelectric power will continue to play a crucial role in our energy landscape. With its potential to provide clean, reliable power on a large scale, it's a key piece of the puzzle in our quest for a sustainable energy future. Let's take a moment to summarize what we've learned about hydroelectric power. We've journeyed together through the fascinating world of hydroelectric power, starting with its basic principles. We learned how this ingenious system uses the power of flowing or falling water to generate electricity. The water's kinetic energy is transformed into mechanical energy by a turbine, which then drives a generator to produce electricity. This process, as we've discovered, is not only renewable but also emits no greenhouse gases, making it a sustainable and environmentally friendly option. We hope you enjoy our video, and if you want to know more interesting facts on more different topics, then please show us some love with a like, share and subscribe. Thank you and have a nice day.